3.6. Okay, what's the distance from a point to a line? It is the distance of a perpendicular line segment from the point to the line. So, distance of a perpendicular or I should have divided that there if I did. Anyway, line segment from a point to a line. Okay. Ooh, distance. What do we know about distance? Yes, we are going to have to use the distance formula. So remember, the distance is the square root of the difference in the x's plus the difference in the y's squared, because that's the Pythagorean theorem. Okay? Now, theorem 3.8. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. Because the only way that one could equal 2, and they both equal 180 degrees together, then they have to be perpendicular. And the little symbol for that is this. So you can abbreviate perpendicular with that symbol. Okay, if two lines are perpendicular, then they intersect to form 4 what? Yeah, right angles. If A is perpendicular to B, then 1, 2, 3, and 4 are all right angles. Example 1. In the diagram at the right, angle 1 is congruent to angle 2. What can conclude about A and B? Lines A and B intersect to form a linear pair of congruent angles one and 2. So by theorem 3.8, A is perpendicular to B. Okay, theorem 3.10. If two sides of two adjacent acute angles are perpendicular, then the angles are complementary. If BA is perpendicular to BC, then angle 1 and 2 are complementary. So they add to 90. In the diagram at the right, angle 1 is congruent to angle 2. Prove that 3 and 4 are also complementary. Okay, 1 is congruent to 2, and how do we know that? Yes, it's given. Now what can we say? If 1 is 2, then we can say that PS is perpendicular to PQ from what theorem? 3.8. And so 3 and 4 are also complementary because of theorem 3.10. And remember, I don't like you to use the numbers so much for your reasons. I'd rather you just say So I would put something like they form a, I don't know, complementary pair. Something like that. It's kind of a bad reason, but it's kind of a short proof. So try these and see what you can do with proof on number 2. Now, perpendicular transversals. If a transversal, and remember a transversal is a line that cuts through 2 other lines, is perpendicular to one of 2 parallel lines, then it's also perpendicular to the other. If H is parallel to K and J is perpendicular to H, then J is also perpendicular to K. In a plane, if 2 lines are perpendicular to the same line, then they are parallel to each other. If M is perpendicular to P and N is perpendicular to P, then M is parallel to N. Draw conclusions. Determine which lines, if any, must be parallel in the diagram. Explain your reasoning. Well, lines R and S are both perpendicular to what? X, right? So, by theorem 312, R is parallel to S. Similarly, lines X and Y are both perpendicular to R, so X is parallel to Y. Also, lines X and Z are both perpendicular to S, so X is parallel to Z. Finally, because Y and Z are both parallel to X, you know that Y is parallel to Z by the transitive property. Okay, checkpoint. Go ahead and do that and start again when you're done. Okay, example 4. Now this is the only really hard part of this lesson, so you may have to think about this for a while and even maybe rerun it. Alright, we have 2 lines and we want to know the distance between the lines. So here's one line and here's the other line. To know the distance from them, we need to know we need to have a point on one line and make a line perpendicular to the other. First we have to decide if these lines are already drawn across are perpendicular. So we need to know the slope of everything. Well, let's first get the slope of these 2 lines, R and Q. Okay, so 55 minus 34, and then 91 minus 71. And that equals 21 over 20. So it goes up 21 over 20. Now, let's see about this line. Remember, if it's perpendicular, then we'll have the flipped over opposite sign, inverse, the negative inverse of the slope. So we want it to come out negative 20 over 21. So let's see if it does. 74 minus 34, 29 minus 71. So that equals 40, negative 42, which reduces to negative 20 over 21. Okay, good. They're perpendicular to each other. So that means that I can use the distance, let's go back up, of this little line here that touches both lines. Since it touches it at a right angle, we can say that that distance is the distance across. So let's put it in the distance formula now. So let's take the difference between the x's. So 29 minus 71 squared, and then 74 minus 34 squared. Okay. If you put that in your calculators, you would get 58. So the width of the track is 58 inches. All right. So let's review this one real fast. If I have a graph and I have a line on that graph, and I want to know how far it is from this point to that line. Okay. I would need to know the equation of the line perpendicular to that one that goes through that point. Okay. And we already know how to do that, right? We take the slope, flip it over, opposite sign, put in this point for the xy, find the new b, and then we have that equation of that line. Then we need to find where the lines cross and take the distance formula between these two points right here. So it's a little bit complicated, but we can do it. Okay, go ahead and try that checkpoint at the bottom, and that's it for this lesson.